Okay, so. This is the one that actually says this is the exact same question on the quiz. First one?
No, I never got the review and I forgot how to do that.
Whoops.
So.
Yeah, that was the only one that was,
Yeah, I wasn't here today.
That's right.
Review, and so that one I just wrote, sorry, forgot.
that's all right. You might pass it by still.
The first question I didn't know.
No, stop.
Man.
Wait, on this last quiz?
Okay, so, people at home, I apologize, I'm handing out a review sheet. So,
I don't remember any of them.
okay, that's why we're going to go over this. So, for people at home, we're reviewing for a quiz that we're going to take next Tuesday. You'll take it next Wednesday in the library, the media center, whatever. So, people that are at home, you might want to download this worksheet that I have as a PDF on Schoology. So, if you don't already, get your unit circle out. And I will tell you this, on your quiz, I will provide for you a filled out unit circle, okay? So I will definitely give you that. And I'll do that. If you're like, well, can't we just use our own? The answer is no, because I'm guessing if you've been doing what you're supposed to do, there's a whole lot more information on your unit circle, on the front or back of the unit circle, that you could use that you shouldn't need to use. You should know the stuff, okay? All right, and some of this is going back to like the second day of school this year, so it's been a while, okay? And it's good that there's 25 questions because that means that they shouldn't take quite as long. I mean, those graphs, some of those graphs you did yesterday took 5 minutes or so. A lot of these only take a few seconds or so. So we look at question number 1. It says draw a negative 120 degree angle. Negative 120 degree angle. So in case we've got how to do that, we draw our XY coordinate plane. Remember, counterclockwise is positive, clockwise is negative, so a negative 120. Well, 120, if it was 120, here's 90, so 120 would be right about here. So negative 120 would be right about here. We start here at positive x-axis, and it would go like this. Negative 120 degrees. That's all you got to do. Okay? And the positive x-axis, right about there.
Show the graph lines.
Yeah, I'd like you to have the XY coordinate plane, just as a reference. Okay, number 2. 4 pi over 3. Same thing. Now they want you to draw a radian angle. Okay? So, all right, so if you really, really wanted to, this is not the way I'm going to do it, but if you really wanted to, you could make it into degrees. You're going to have to do that on some questions later anyhow, but let's do this. All the way around is 2 pi, so halfway around is 1 pi. We're at 4/3. That's 1 1/3 pi. So if I went like this, here's where I start. Right here is 1 pi. That's a whole pi right there. Now we have to go another third of a pi. A third of a pi. Now be careful right here, okay? This is a whole pi, so a third of it's going to be, is that about a third, would you say? Or does it have to go shorter or farther, would you say? A little farther. Should I go all the way? I mean, if I go to here, is that far enough? It's too far. So right about there. Okay? 4 pi over 3. So I went all the way or to 1 pi, then about another third.
I just bring it back to so I brought it to 8/6 because
Okay.
then you're just working with 30-degree increments.
That works. That's fine too.
8 of those.
Same thing. Yep. Number 3.
Oh, man.
Okay, convert 79 degrees, 42 minutes, 21 seconds. 79, 42, 21. Oops. So it was 79, 42, 21. Okay, they want it in decimal degrees, round to 2 decimal places. Round this to 2 decimal places. So we know it's going to be 79 point something. 79 point something degrees. Okay? So this is one that you'll need a calculator for. And what we need to remember is we have degrees, minutes, and seconds. There's 60 minutes in a degree, and there's 60 seconds in a minute. Therefore, there's got to be 3,600 seconds in a degree. So what you would type in is, and I would really encourage, if you type again, type it in parentheses 42 divided by 60 plus parentheses 21 divided by 60. I have no idea what that is. Somebody want to punch it in If you guys use your phones, it's fine. It's gonna be 0.7-ish. Whoa, I messed up. Whoa, I made a mistake. Sorry. Not divided by 60. I said it once, and then it's not. There's how many seconds in a degree? Not 60. 3,600. Sorry. I made several of you jump. I'm sorry on that. I just don't want you. Yeah, 21 over 3,600.
0.706.
706. Somebody else get that?
I don't think anybody else did it.
He's doing it.
I got.
Did you do plus the? Do plus 0.7. This is 0.7. I know that. 42 divided by 60 is 0.7. So 0.7 plus,
0.7 plus.
then parentheses, 21 divided by 3,600.
0.7.
0.7 what? 06? Okay. Now it says 0.706. If you put that down, I probably wouldn't mark you wrong, but I want two decimal places, so it'll be 0.71. Okay. Number 4. Okay, 28.24. Yeah. Okay, they want it in degrees, minutes, seconds. So we know it's going to be 28 degrees. We got to find out how many minutes and how many seconds. And again, it's been a long time since we've done these ones, okay?
Divide 28 by.
Not 28.
5.
No, we don't, we're already dealt with the 28.
Oh, yeah, the 24.
Take 24 and work backwards. You times 60, because there's 60 minutes in a degree. And, well, say not 24.24. And what is 0.24 times 60? Is it like 14.4? I think.
Yeah.
It is? Okay. So 14.4 what? 14.4 minutes. So how many full minutes are there? 14. And we have leftover minutes, leftover parts of a minute. And parts of a minute are called seconds. You guys remember what we do next? It's been a long time. We take just the decimal part again, 0.4, and then times by 60 again. We get 24. Okay? We take the whole degrees, just write it down, 28 degrees. Take the fractional part, the decimal part, times 60, then take the new fractional part, times 60 again. Okay, so 28 degrees, 14 minutes, 24 seconds. Okay. You're going to be given a unit circle on this quiz. Can you use unit circle on this one? They want you to convert it to radians. Nope, you don't see 340 degrees written on your unit circle anywhere, okay? Now, right now, I see several of you doing it. You're flipping over your unit circle and looking at how to do it, and that's fine. Can you flip over your unit circle on your quiz? It ain't going to be there,
I mean,
okay?
Give it to us, we could.
Yeah, it's right. If I did, which I'm not. So anyway, times by pi over 180. And 340 times pi over 180 is 340 pi over 180. And you guys know, most of you had me previously, you know the answer to this. I mean, this one simplifies, so we need to simplify it. Will the one on your quiz simplify?
Probably.
Yeah, probably?
No.
Definitely will. If it's not going to be 340 degrees, it's going to be something different, but if it simplifies on the review, it's going to simplify on your quiz. I think the biggest thing that goes into them is 20, I think. And well, 10 does. I know 10 does. Okay, do that. 10 goes in 34 times. 10 goes into 18 times. It simplifies, but it simplifies further. 2 goes into both of those. 17 times and 9 times. Had you just picked 20 the first time, you'd be done in one step. So, which is the right way to do it? I don't care. But if you pick the biggest number, you're done in one step. Okay, 5 pi over 12. This is another one that you can't use unit circle on because you don't see 5/12 pi written anywhere. So to make this into degrees, on the back of your unit circles, it says times by 180 over pi. And you don't have to know this, but the suggestion I give to you that doesn't always work is, how do you know it's probably times by 180 over pi rather than pi over 180?
Because if there's a pi on the bottom, you can cancel it.
Yeah, okay. Now the pi's don't always cancel, but if you had pi over 180, they're not going to cancel, okay? So that doesn't always work, but it works on this one. It'll work on the one on the quiz. Cross off your pi's. 5 times 180 is 900. Over 12 times 1 is 12. We take 900 and divide it by 12, I think it's 75 degrees. Yeah, it is.
What does it say?
We're at,
It's 900 over 12?
and that's 70, yep, that equals 75 degrees. We going too fast, too slow, just right? Okay. Number 7. Okay, I gave you the arc length formula. Will I give you the arc length formula on the quiz? Yeah. If it's on the quiz, it's on the review, it's on the quiz. You don't have to know what this is. Just understand there's 3 things.
You plug them in.
Plug in 2 of the 3, find out the other one. Okay? So number 7 says S equals theta R. Okay? S is 10. That looks like 5 is 10. Okay, that's supposed to be S is 10. So plug in 10 for S. Theta is 1/2 times R. Okay? Also, theta is supposed to be in radians. And was it in radians or not? Whoops, hang on a second. Why did I put S? Must be a 10 there, sorry. Did I give you radians or not on number 7? Yeah, how do you know that?
But that's not a-
Because it says radians. Will it be radians on your quiz? Yep. Okay, how do we get rid of that half? Multiply by 2 over 1. That's just 2, it's 20. Or just you use common sense. Half of what is 20? 10. Or half of what is 10? 20, sorry. Okay, I'm going to give you the sector area. Remember, if in case you forgot, arc length is the pizza crust. Sector area is how big of a slice it is. Okay, so we have A equals 1/2 theta R squared. A is 8, 1/2 theta. We're trying to find out what theta is. And R squared is 6 squared. So just plug in what you know to find out what you don't know. So 8 equals 1/2 theta times 6 squared is 36. And I'd do this. It doesn't matter what we're already multiplying in. I'm gonna multiply 1/2 times 36. 1/2 times 36, 1/2 of 36 is 18 times theta. Last thing we do is divide by 18. And I don't care if you make them fractions or decimals. I'm going to leave it as a fraction, but the fraction needs to be simplified. 2 goes in 4 and 9 times. And be careful. I've seen students, seen very smart students in years past have an answer like 4/9, and they'll say 4/9 simplifies to 2/3.
No.
No. How did they do that? Where did they get 2/3 from?
They tried reducing both numbers to the
Square
lowest.
root.
They square rooted the the top or the bottom? Both. That doesn't work. And here's why. I mean, think about it. If you win 2 out of 3 games, that's more than half. 4 out of 9, it's not more than half, okay? Square rooting the top and bottom doesn't work. We've been saying for years, whatever you do the bottom, you do the top. It's got to be by multiplying, though. 4 times dividing, okay? Not by square rooting. All right, number 9. Okay, this point is on the unit circle. Find all 6 trig functions, okay? So, sine of theta, cosine theta, tangent of theta, cotangent, secant, and cosecant. Okay. Do we know what sine is? Or not? Yeah, what is it? Careful. Negative 2 root 2 over 3? Negative 2 root 2 over 3. Do we know cosine? 1/3. Okay. Let's find tan. How are we going to find tangent? We already got sine over cosine right here. And the denominators are the same, so wipe them out. So those are gone. We have negative 2 radical 2 over 1, which is 2 radical 2. Probably the easiest one to find next would be which one do you think? Cosecant, secant, or cotangent? Secant's what? 3 over 1, which is just 3. Okay. Let's do cosecant next. It doesn't matter what we're doing. And to find cosecant, we flip sine. So it's 3 over negative 2 radical 2. But we can't have radicals on the bottom, so we times, and again, I said in algebra 2, you times the top and the bottom by the bottom. You don't have to times by the entire bottom, just times the top and the bottom by the part of the bottom that we don't like, which is what? Times radical 2 times radical 2. 3 times radical 2 is 3 radical 2. Radical 2 times radical 2 is radical 4, which is 2 times negative 2. Radical 2 times radical 2 is radical 4, which is 2 times negative 2, which is negative 4. And this is over 1, so cotangent's 1 over negative 2 radical 2. Again, we times our radical 2. 1 times radical 2 is radical 2. Radical 2 times radical 2 is radical 4, which is 2. Times negative 2 is negative 4. Okay. This is one that I'm going to show my work on, but you really shouldn't have to show your work on it. Negative 7 pi. Where the heck is you don't see negative 7 pi written on your unit circle, but negative 7 pi, that's negative 1 pi, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. And the sign there is what? 0. Sign's the y value. So it's 3.5 times around. $11. Find 7 cosine 90 minus 3 sine 27. You need a calculator on this one or not? Shouldn't. How are we going to find the cosine of 90? How are we going to do that? Yeah, you look at your circle. So 7 times, what is the cosine of 90? Minus 3 times sine of 270, what's that? So we just plug stuff in. 7 times 0 is 0. Negative 3 times negative 1 is positive 3. We're just looking at the unit circle. Okay, number 12. 2 secant pi over 4 is 4 cotangent pi over 3. Do we have secants written down on our unit circle or not? How do we find secant? Flip cosine. Okay, so 2 times, okay, we look at pi over 4. What's a cosine of pi over 4? Radical 2 over 2?
Yeah.
So secant's what? 2 over radical 2?
Yeah.
It does simplify. Isn't that correct?
Yeah.
Okay. And we'll simplify it. Okay, for cotangent, we look at tangent and flip it. And what is cotangent at pi over 3? Is that radical 3? Yep, radical 3. So reciprocal would be, if it was radical, it'd be 1 over radical 3. We'll deal with that in a minute. Reciprocal radical 3 is 1 over radical 3. Okay, any questions on this one so far? Let's clean this up. We times just the top by 2. 2 times 2 is 4 over radical 2, plus 4 times 1 is 4 over radical 3. And we can't have that for an answer. We have to times the top and bottom by radical 2 here, and times the top and bottom by radical 3 here. 4 times radical 2 is 4 radical 2. Radical 2 times radical 2 is radical 4, which is 2. 4 times radical 3 is 4 radical 3. Radical 3 times radical 3 is radical 9, which is 3. We can simplify this a little bit. 4 over 2 is 2. Radical 2 plus 4. Not very nice answer, but that's what, is what it is. 2 radical 2 plus 4 radical 3 over 3. Is that what you guys want to do? Get 15 of them done, then 10 tomorrow, and then just do this? Does that sound like a doable? Okay. All right. Yeah, we'll definitely get, no problem, do 15 of them today. 13. Find all 6 trig functions of 13 pi over 6. Okay. You don't see 13 pi over 6 written on your unit circle, but we're going to use our unit circle. Do you guys remember what we do on these types of problems? I'll give you a clue. It's an improper fraction. 13 over 6. How do we make that a mixed number? 6 goes into 13 twice. 2 with what left over? 2 and 1/6 pi. Okay. So 2 and 1/6 pi. So where's 2 and 1/6 pi at? Where's 2 pi at?
Here.
All the way around. So what are you guys going to look at? What's that? How many degrees? 30 degrees. You're going to look at 30 degrees. With that being said, are you going to write the sine of 30 degrees? You should write the sine of what? 13 pi over 6 equals cosine tangent. Cotangent, secant, and cosecant of 13 pi over 6, 13 pi over 6, 13 pi over 6. Okay, so we're going to look at 30 degrees. 2 and 1/6, 2 and then 1/6, right about there. That's where we're looking. All the way around, another 30 degrees. So what's the sine of half? So cosecant's 2. Cosine's root 3 over 2. So secant's 2 over root 3. Times my root 3, you have 2 root 3 over 3. And tangent's what? Radical 3 over 3? You guys remember that little shortcut? What's the reciprocal of a radical number over the same number? Like if I gave you radical 23, the reciprocal of radical 23 is radical 23 over 23. Say it again? Well, in this case though, not just 3, careful. Radical 3. That's what you meant, right? And again, I apologize for, we should have given you a test over this like 2 weeks ago. And I will say this, and that's my fault, but at the same time, this is like the meat of trigonometry. I mean, this is stuff that you gotta know. I mean, I'll be honest with you guys, stuff like arc length, sector area, those aren't huge, okay? But these are ones, this is what trigonometry is, okay? So this is stuff that you gotta get out of this class. Say, 405 degrees, where's that at? Where are you guys going to look at? 45. How'd you get to 45? All the way around? 45 more. So sine, cosine, and tangent of 405 degrees. Cotangent, secant, and cosecant of 405 degrees. Okay, so we're going to look at 45 degrees. The sine is radical 2 over 2. So is the cosine, and the tangent is 1. Cotangent, what happens when you flip 1? It's still 1. Reciprocal of radical 2 over 2 is radical 2. Both radical 2's. Oh. You guys know how to do 15? You're right, you don't know how to do it because we skipped over this. The reason was, and I'm going to skip over it, what the heck, it'll be a freebie point. You know how you do it? If I asked you this, if I asked you for the sign of 45 degrees, how do you do that? You know, there's a unit circle. What if I asked you for the sign of 47 degrees? You know how you do that? You use a calculator, okay? You use a calculator. Weren't using those because we weren't supposed to use calculators, and we haven't been using calculators in this class other than on your own phones. But as long as I clean off my algebra 2 classes has to use them from time to time, so they've been using them. I've been wiping them down with disinfectant wipes and stuff like that. But for you guys, just don't even worry about it. Number 15 will be a freebie point. Okay? All right, so we're done for today. Again, we'll hit the other 10 tomorrow, and then on Monday, we'll do a pre-test, and the actual test is Tuesday.